G'day, Seve. How you doing?
Hey, Matt. I'm doing pretty good. I almost got beat up in the street.
Today?
No, yesterday.
Oh, thank God. Wow. No, please tell.
So, I'm from New York.
Okay.
And
so
I'm
you're
from
hard.
I'm from New York. I'm from upstate New York, but I still do New York things like eat on the street. So I'm walking down the street. I'm eating a sandwich.
Wait, sorry, this is a New York thing? People here don't eat while they're walking around?
I don't think people eat on the street. Do you see people? Do you eat on the street?
Yeah, I mean, why not? I'd prefer to sit down, but that's what burritos are for. They're just like a prepackaged.
Oh, absolutely. Absolutely.
Okay, so sorry, but you're walking down the street eating.
I'm walking down the street. My face is full of sandwich, and I'm walking on a crosswalk, and some guy is like, you know what? I can beat this pedestrian. And so he floors it and just goes like, I could have reached into his car. He is like right in front of me. And so through my muffled tones, I go, "Oh, for you, man," And then he slams on the brakes, gets out of the car.
No.
And he's like, "Oh, you want to go?" Blah 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 blah.
It's like, clearly you want to go. You're driving pretty fast.
He definitely wanted to go.
Well, different kind of go, but yeah. What a douche.
Yeah.
Did you wait? Was the light red and you just like walked across the intersection?
No, it was a stop. It was like a four-way stop.
Oh, God, okay. Yeah. Terrible intersection.
Clearly right of way. I know people are, they're probably like, oh, he's eating a sandwich. It was like, no, it was a pretty clear cut.
No, it was definitely, no. And even then, the reason the road rules are set up the way they are is you have the right of way. Right. He is clearly supposed to stop. What a douche.
He was a bit of a douche, and then he got out of the car and kind of challenged me.
Exemplified his douchiness.
And I'm not a violent person,
Really?
I haven't been in a fight since my hockey days.
Oh, damn, yeah.
Yeah.
You didn't have your stick with you? None of your armor?
I didn't have my stick. I didn't have my armor.
Didn't want to get sued?
Actually, I was in flip-flops, and that was really the thing that decided it for. Like, I looked at the guy, and I was mad because, I believe in right-of-way.
Yeah.
I'm a big believer.
I believe in my rights of way.
Another random thing that happened recently is Tesla released the report and that said autonomous cars are like 1/10 as likely to hit pedestrians.
Yep.
And like, car accidents are so scary. Like, we just need to get people out of the cars.
Oh my God.
And then I wouldn't have to fight people in the street. But anyway, so he kind of challenges me and is cussing out and he's out of his car. And by the way, like, now traffic is stopped because he's out of his car. The car stopped in the middle of the street. And then I'm like, I'm looking at him like, do I want to engage
him your
here?
Hot dog or?
Yeah, right. I almost threw the sandwich. I was like, first thing I'm going to do is throw the sandwich, right? Because that's like all over him. That's going to be a concern. He's like, you don't just walk through a sandwich. You go, did I get mustard on me? But so as I said, I had a big bite of sandwich in my mouth. So I was looking pretty scary because I was picking that sandwich out of my teeth. I hung up like that, Yeah. So I had a pretty scary look on. But ultimately, I looked down and saw that I had flip-flops on and decided it wasn't worth it. So
nice.
I went, sorry, sir.
I'm so sorry, sir.
I'm so sorry. That was me. That was totally me for being on the crosswalk. And
not even just a casual, like, nah, I'm good.
I don't know. Yeah.
Wow. What a way to start the day. A little bit of adrenaline, a little bit of adrenaline. There's a lot of anger in people sometimes, Yeah. You gotta ask how you doing, buddy?
Really, he needed support. Really, he needed a hug. He got out of that car for a hug, and I should have recognized that.
Come on, buddy. Bring it in. I don't know if I would have been brave enough to try, but what a world we live in when you could.
Yeah.
Damn. Well,
how's your day? How you been?
I haven't fought anyone, which was nice.
Nice. Better than last week then. Yeah. That was rough.
yeah. Damn. Jesus. No. I'm very well, thank you. I guess my ride away is typically on a bicycle, but I feel much safer around the Waymos than I do a regular car.
Yes.
And to what we discussed last week as well, I think with the independence mindset I'm perhaps inheriting from your Americans in some way or another, sometimes I find myself like going, I could just walk in front of this Waymo. It's going to stop. because, you know, you can just bully them. It's got a LiDAR. It sees me.
Oh,
with,
absolutely.
Like, precision down to the millimeter.
Yeah, and you're not bothering a human, right?
Well,
that human is more of a second degree. And they're probably watching TikTok because,
They probably don't even know that someone walked in front of the car. No, but I do feel much safer cycling around the Waymos as well. I'm sure that no matter the conditions, it can be the middle of the night, dark as anything. That thing's got like 6 cameras and 1 million LiDAR points hitting me, and I know I'm with a lot more confidence.
Absolutely, it's gonna. It kind of stays away too. It keeps the right distance, and you can't trust normal cars.
No.
Like 1 in 20 people is gonna get a little too close.
Yep, absolutely. And I certainly hope the same from Tesla too. I've currently got 12.5.6 or something on my Model 3. And it's incredibly impressive, right? Technologically, it's awesome. But also watching the robotaxi announcement the other week, I was watching this on my phone and I was watching it on X and the live stream, and I saw Elon mention, yes, it was in 2025, we will have FSD public without people. And then I immediately flipped over to Robinhood to see what the stock did and went, and I should, because, they say buy the fundamentals and sell the news. And I knew it was news. I should have sold it that second. I was so tempted, but I didn't. I didn't. And anyway, but I do genuinely think they can get as good. They can get really good too. And
I think so.
Good for all of us.
I think so. Yeah. And I think right now the scoreboard for Tesla and Waymo is fully autonomous, and they have teleoperation take over. They actually work. They're deployed. They have a taxi service. They're doing pretty well. Mm-hmm. And I think some people have even looked at them side by side and said Waymo is a lot slower getting places than Tesla is.
It is.
So maybe Waymo's benefiting from some of that more conservative driving behavior.
Yeah. But the other question is, do you mind if it's a little bit slower, if it's nice?
No.
Don't
all.
care. Couldn't care less.
Not at all.
No, I take them instead of Ubers whenever I can, reasonably,
Yep, absolutely.
If they're like even 20, 30% more expensive, I'll typically get a Waymo, and it's also 20, 30% longer duration. And then if it's more than that, I go, okay, come on.
There are times where Waymo fails. So I had to go to a conference the other day in San Francisco, and there were so many pedestrians and all this going on that it had teleoperation takeovers. And so I do think we'll see that as Waymo start to take people to airports and stuff like that. And they've just started taking people to airports in, I think, Austin or something like that.
Phoenix, maybe?
Phoenix. Yeah, that's right.
Cool.
That's right.
Just another desert, hey?
Yeah. But crowds, those are hard to navigate because you have to be aggressive. You have to signal like one of us is going to get hit and it's not going to be me,
When I used to drive an old Beta, so this Model 3 is the only car I've owned, and my parents had this old Beta. It's a Commodore. It's a model of Australian car from Holden, which used to exist, and sadly GM got rid of the brand during the pandemic. But
oh wow,
the old Australian car brand. And it was truly a Beta, and it was one of those cars in traffic people would give you space, and it was fantastic because you just drive around. You need to park, you can park. It's fine. People aren't going to run into you. What are they going to lose?
Yeah.
So that's a good way to be. It is a lesson though in psychology. Is if you make an experience nice, you don't actually need to optimize around things. I remember recently seeing the same thing about elevators. They'd like put some art in the elevator instead of investing what was like tens or maybe $100,000 to upgrade the lift motors and the brakes and the cables and the whole system. And you can be clever sometimes. I quite like it.
Absolutely. A classic case in web development is loading bars. Fake loading bars will get people to wait longer.
Absolutely.
Even if they're totally fake.
Even if that's why they jump at the end.
Yep.
Or the dinosaur game in the Google Chrome browser when you can play jump over the little posts or whatever it is.
Yeah. What?
When it 404s, I think.
But wait, how is this a psychology? Wait.
Well, you've just had an error, you had a 404 or whatever. Or
it makes you like less mad.
No, you get to play
you hit the 404. It's fine. Well, I guess I get the dinosaur game.
And plus, I get mad at AT&T rather than Chrome then.
It is fun discovering companies' 404 pages and finding out they did like a custom drawing or something like that on the page.
Sorry, not the 404 from Chrome, but yeah, you're right. Other errors from Chrome, but yes, custom drawing and all good stuff. Shall we jump onto the product highlight for today, Seve?
Let's do it.
So what I have for you to hear is this was dropped on our off-topic page on our Discord. It is the Sign Core CNC lathe. It is a Kickstarter. and this page is very dark, so I'll jump into the next for you. It's a Kickstarter project for a compact CNC lathe that the starting price for, if you get the basic version without their like tooling kits and whatnot, is under $5,000.
Wow.
It's $4,479. And that's the early bird granted, but it's $4,779 for the Kickstarter machine only, which is incredible because a CNC lathe it's the stuff you can do with this. The last time I used one personally was a project back home where a couple of buddies and I we wanted to build a liquid fueled rocket engine. And so we decided we had a week, evenings and like mornings and whatever we could squeeze in around our day jobs basically to try and make this happen. And without this thing, we would have spent a couple of $1,000s on fittings. But you can trivially cut up, put in some stainless bar and machine custom swage fittings.
Oh, huh.
For whatever you like.
Oh, very interesting. I never thought about that as like, I don't need to buy this part. You know, a lot of parts are radial because usually I think like, oh, I'm going to get the best value add out of like regular CNC non-lathe. But there are a lot of stuff you can only do with the lathe.
There's a lot of stuff that is just like well and truly best done with a lathe, like anything concentric.
Yep.
You know, all of your fittings, anything that pokes things, you can make custom, not quite drill bits, but like auger bits and whatnot that hold other tools or cutting bits inside them.
Oh, yeah. This one is really kind of OP too. It's got, for less than $5,000, you're getting the ability to change tools. It has a tool changer.
It has an ATC, yep.
It has coolant.
Yep.
Wow. Huh.
Fully enclosed, fully CNC controlled, and it also has active tooling as well, which is a pretty cool lathe feature that you don't always get. Basically, you can put a drill on the gantry, and so that you can drill offset holes and all sorts of things.
Oh, huh. Yep. Okay, very interesting. Oh my gosh. I wonder what are the like 10 most common things made with a CNC? That's what I'm
with a lathe.
Or with a lathe, yeah. Most common lathe made products. I'm trying to think, when does the last time I needed a lathe though? I feel. Okay, let's see. Google's not hitting it too hard. Screws, candlesticks, gun barrels.
Candlesticks? Gun barrels? Come on. The ATF's going to kill us.
Table legs, bowls, baseball bats, musical instruments.
These sound like wood lathes. Yeah.
I mean, for rocketry, I can see it because everything is cylinder-esque. Yeah. And that makes a lot of sense. Yeah. Aerodynamics. So anything going through air is probably going to have a cylindrical element to it. Although, you can get a lot of smooth stuff out of... Matt, I'm just not sold on lathes right now. You know, like, sell me a lathe.
Sell you a lathe. Well, so the custom rocket in a week wasn't for you? You don't
Custom
need
rocket is pretty cool, but I don't see, the thing is like, I'm really afraid to launch a rocket. Don't you need like clearance to launch a rocket or something?
Only if you get caught. No, and like half the fun's frying the engine anyway. You put it on a sled, you weigh it down, you hope it doesn't take off.
I do feel like it should become like a hello world of engineering to do a self-landing rocket. That should
would
really
be the day.
Or now the Mechazilla grab arm.
Grab
that
rock.
also happened since last time we talked.
God,
the friggin' rocket being caught by Mechazilla.
Oh, incredible. That's one you couldn't have missed, though. We don't need to report that in the news.
That's very true.
Yeah, wild stuff.
But
the main topic for today.
Yeah.
So the main topic for today I've got for you is about e-waste. Now, this is unfortunately a much less fun topic than we often cover, but it is an important one. You have to ask yourself, like, where does what we design go at both the end of its life, and also to some degree, what are the outputs of the manufacturing processes, which is something you mentioned last week as well.
Yeah, and who pays for the externalities? Right?
Yeah, and who pays for the externalities? The actual payment for the externalities is only something I've got a little bit of touch on in front of me, but it is an incredibly interesting question. What is your opinion?
So yeah, this is something I'm trying to figure out myself. So I don't know if I have a strong opinion yet, but I do know when I was at PCB West, people were like, there was a German guy I was talking to, and he was like, why does the U.S. want to bring dirty industries back to the U.S.? Like, there's a reason they were kind of sent somewhere else. And I think with PCBs, because they're kind of like chips, people don't necessarily see them as sort of a dirty thing to make, but PCBs have a lot of chemical processes and a lot of e-waste.
Chips are dirty too.
Chips, yeah, I guess I don't know the delta or the relative difference or anything like that.
Yeah.
PCBs versus chips.
Chips are extremely dirty as well. Like the bulk quantity of chemicals you need is obviously lower because you're making like tiny things. You're making extremely small structures. But the problem with chips is that you're using insanely dangerous chemicals. Like you're using a whole bunch of like fluorinated acids to etch what is ultimately, glass, like layers, right? You're putting a whole bunch of glass in this thing. And in order for something to attack glass, it has to be pretty nasty, pretty reactive.
Yeah.
And so you're using like hydrofluoric acid fairly readily and whatnot. And all sorts of etchants back and forth and then you end up consuming a whole heap of water, which is the other problem with the new labs built in Phoenix, or the fabs built in Phoenix, is they don't have a whole heap of water.
Really?
No.
So where is water used? Is it for cooling?
A little bit. Have you ever heard a chemical engineer say the solution to pollution's dilution?
Oh, okay, gotcha.
You water it down sufficiently, and there's some degree of truth of it. Depends on the persistence of a contaminant. If you're talking about something that will readily break down in the environment in, whatever, day scale in UV light, then okay, fine. Dilute it, dump it. It will be processed sufficiently by the earth. We don't need to worry about it.
Right.
Like CO2 is a perfect example of this. Like we breathe it out. If you breathe a room full of it, yes, you would get poisoned. It doesn't matter. We have trees. The trees process it, and it comes out clean. Like no worries.
Right. Makes sense.
But then on the other end of things, you have persistent environmental pollutants, which are things like PFAS, very famously recently, right? You've heard of PFAS in groundwater.
Probably should have. PFAS. What is PFAS?
PFAS is there's a class of chemicals. There's a bunch of them used for things like waterproofing coatings and bonding Teflon to things and all sorts. And firefighting actually was a big environmental contaminant of it. The US military used a lot of it as firefighting foam. Yeah. And it just gradually seeps down to groundwater, and it is extremely stable, which is what makes it useful in all those applications. But it's stable. It's going to sit in the groundwater for a long time. It's extremely hard to filter out and in very low quantities.
So this is where I come clean on something. My only C in college was my Chem 101 class. Okay. So stable. When we're saying stable, non-flammable?
Right? Yeah, unreactive in general.
Unreactive, okay.
But like both not flammable and doesn't really, break down in, general room temperature, not too much UV kind of conditions.
Doesn't break down, so nature can't get at this stuff. It's like attacking those neutrons. What's in an atom?
You certainly don't want to be breaking down the atoms yourself. Then you end up with nuclear processes.
Right.
But you want to break chemical bonds between things and break it down to common, simple molecules that both our bodies and the environment's used to processing.
Gotcha.
Right.
Gotcha.
And so for and it's, as it's also the case for like e-waste. Basically, is you end up with something large and extremely complex, right? Chemically very complex. And how do you get this back to useful constituent metals, which you can recycle? Like there's plenty of copper in e-waste, for example.
Right.
How can you get that out in a useful form again?
Yeah.
And then simultaneously, you've now got plastics, which are full of flame retardants, right? Because they have to be in order to meet the underwriter's laboratory specification, UL 94 V0. And those flame retardants are often using halogen compounds, which are bromine, iodine, chlorine, and fluorine. And then some nuclear stuff that you don't touch, right? But those four compounds are extremely, extremely reactive and therefore extremely, extremely dangerous. And so when you bind them up in these plastics, you end up with something that's like very hard to break back down again into stuff that's sufficiently simple to be what we would deem safe just in the environment or, just natural, right?
Right. And I think with recyclables, there's been kind of a shift towards aluminum bottles and stuff like that. And maybe that's like a shift from saying, okay, how long does this take to break down to like, okay, how do like, easy is this to like reprocess? Because I think aluminum is very easy to reprocess.
Yeah,
is that
extremely
right?
so. Yeah, definitely. Yeah. So the thing, like aluminium bottles are, extremely interesting example because, both an aluminium bottle is extremely easy to recycle, which is great. It's relatively low energy to recycle compared to glass. I believe that to be true. You've got a lot less material to heat up, so it's cheaper to recycle, less energy embodied in it. It does actually have a plastic liner on the inside, right?
Oh, really?
So when you throw it in a smelter, you just burn that plastic off, basically.
So wait, so the aluminum bottles have plastic on the inside?
Yep,
You're
exactly.
kidding.
That's why they're not dishwasher safe.
They're not?
No. That's why they say don't put it in the dish. Like the thin ones that you
they
buy.
Have plastic
like
on the inside. My mind is blown. I thought it was just pure aluminum. Why don't they just use pure aluminum?
It's the same as an aluminium can, right? They're lined.
What?
Yeah, they've got a liner in them. They've got a thin plastic liner. It looks like a plastic bag. If you dissolve the aluminium in sodium hydroxide, or a sodium hydroxide solution, you end up with a little plastic bag. You can do this with a Coke can while it's still full.
Wow.
Yeah. So
have they always been like that?
Mm-hmm.
That's crazy. Yeah. I had no idea.
And so you want to talk about microplastics and endocrine disruptors in your food? Well, is canned things the best? And even tin cans, they're not lined with tin anymore. They're lined with a plastic liner on the inside. That's why they say BPA free, they're bisphenol free, because there's plastic all
Oh my gosh, you are blowing my mind right now.
Yeah.
Maybe everybody else knew this, but I thought the aluminum cans were a reaction to microplastics. Like we are getting away from microplastics.
Yeah.
And I might even have been slightly not plastic leaning and going for the more metal things.
Yep.
But they all have plastic on the inside.
Yeah, glass is where it's
All for
at.
naught.
If you want something that is purely unreactive, just like it is a benign bottle, glass is pretty good.
Glass is best, but then it's not recyclable. So
it is quite recyclable. It takes a bit more energy to recycle than aluminium, and transport costs are high because it's heavy in itself and they break, right?
Okay.
Aluminium's durable. You leave it in your bag, you throw your bag around, no worries, right?
Okay. Wow. Wow. Okay.
So
mind-boggling.
This is the complexity behind breaking down e-waste in the same way that you might have a circuit board that has a whole bunch of copper on the front, but it's got a whole bunch of plastic, which is the matrix, the epoxy typically on the circuit board. And that plastic is complex because it's filled with fire retardants and all sorts of adulterants and fiberglass.
So understanding what a PCB is made of.
Yep.
There's the fiberglass, and then there's the copper. The fiberglass part includes the epoxy. That's how the fiberglass is put together.
Yep,
is that
exactly.
Right? Okay.
It's a fiberglass composite, right? Where you have a matrix, or like the plastic that encompasses all of the fibers. You have typically fiberglass weave matted, multi layers, and then you have typically it's an epoxy resin, not always, but typically an epoxy resin that has additional flame retardants added to it.
Gotcha.
Typically bromine based ones.
And we've really settled on that substrate, if I'm not mistaken.
FR4? Oh, yeah.
yeah, we've really settled on it. So this is just kind of the superior balance of, I guess, I don't know, it kind of conducts heat, but definitely not electricity.
Definitely doesn't conduct electricity, doesn't catch on fire.
Doesn't catch on fire.
Easy manufacturability.
So it's sticking around.
It's typically, there are changes to it that are important. Those halogen compounds I mentioned, the chlorine and the bromine typically are the ones that you'll encounter in a circuit board. But there are halogen-free circuit boards that now actually are a significant portion of boards made.
Really?
Right? Yeah.
So FR4, that's something we're going to see on like a PCB checkout page.
Yep.
Are there like other big names to be aware of if you do want to reduce e-waste or just be aware of what's going on?
The FR4 is a flame retardancy standard, right?
Oh,
and
so is it FR flame retardant?
Yes,
is that
exactly.
Right? Okay, learning a lot. Why 4? Is that the level of?
That's a great question. I think it was a generation, but I'm not actually 100% sure with that. It's either a generation or a level of flame retardancy.
I had no idea. I thought I was selecting a material, but I'm actually just selecting, okay, I want it to be flame retardant.
Yeah, there's a bunch of manufacturers that make a bunch of composites that meet this requirement, right? Like you can get it from everyone from like Philips to Samsung to Shenghe.
So they can really put whatever they want in there as long as it meets that standard. That's FR4.
Yeah, practically. They're not even all epoxy resins, right?
Really?
No, not all of them.
What else is used?
Like So epoxy is also a bit of a misnomer because it's not a specific molecule, right? It's a class of molecules, and sometimes they contain chlorine and sometimes they don't.
I think of epoxy like a sticky glue that is cured by a light sometimes.
It's sometimes cured by light, yeah. It's often a 2-pack epoxy that has a time to cure as well, right?
Gotcha.
Or you cure it by heat is the other way you go around it.
Yep.
And so there's a composite of these factors typically involved in like a industrial manufacturing process.
Sure.
But there's a number of pollutants embedded in these boards. And we're just talking about the circuit board level.
Right.
There's a number of pollutants sort of embedded in them, and now you're stuck with the question, like, what do you do with this now extremely complex thing? It's glass fiber, it's copper, it's some plastic.
It's whatever is in the chips too, because I don't know if chips, certainly LEDs aren't all made with the same kind of material inside that. So you kind of don't know what you have necessarily. If you just have a circuit board, you can kind of guess there's definitely going to be some majority compounds.
And some solder and whatnot. That's why... this is why legislation like the RoHS in Europe is so important, because they've banned a whole bunch of the dirtiest possible things that you could put in circuit boards to make them safer.
So you usually, if you get a circuit board, you can usually safely assume if it's from a consumer product, it's not going to have lead anymore, I think.
Typically,
right? Yeah. And that's definitely RoHS. At least one of the things in there, is that right?
Yes, exactly.
Does the U.S. have something like that?
Environmental standards?
Did we just copy RoHS? I'm trying to think, because I recognize that, but I can't think of a
It's kind of a global
standard.
effect, because Europe's such a big block that if you wanted to sell into Europe, you had to meet the standard. And why would you maintain 2 variants when it's the cost of switching? It's not really the cost of manufacturing.
Yeah.
Like, once you've worked out how to make a material that meets the specification, even the halogen-free circuit boards, the materials doesn't cost anything.
So Europe really did everybody a solid by releasing that. Yeah,
did a huge solid.
It reminds me of the kosherification. I heard somewhere that a lot of food became kosher because it's kind of one extra step to make it kosher, and you might as well just make everything do that once you have it. So
once you got the process, then it's easy.
Right.
Yeah, but maybe first, actually, like what do you think of when I say e-waste?
So e-waste, I'm thinking of a dump full of probably circuit boards is mostly what I think of. But I guess I don't know. Yeah, probably like heavy metals, stuff like that. I don't know.
The sort of the scale of it. It's a dump full of them is one way to go about it. That's an image that comes to mind. But
probably like a landfill.
Yeah, landfill.
Yeah.
What kind of products do you kind of like comes to mind as like an e-waste typical product?
I'm thinking. That's a good question. I mean,
like phones, tablets, the obvious ones.
Tablets, maybe a Peloton.
Yeah. Interesting.
Yeah. Anything that kind of has wires in it. So a TV for sure.
Air conditioner, dishwasher. All of this type of stuff. Yeah.
Appliances.
Totally right.
Yeah.
So what kind of scale do you think we globally generate e-waste on?
Oh my gosh. What do you have your unit in? Is it tons or?
I can give you metric tons, F-150s, or McDonald's cheeseburgers, depending on what freedom unit
McDonald's
you prefer.
cheeseburgers. I'll pick the freedom unit. Thank you. That's gonna be 1 trillion cheeseburgers.
Wow. Okay. Well, thank God the world is better than you're imagining. It is only 310 billion McDonald's cheeseburgers, which is about 27 million F-150s or 62 million metric tons a year. It's a lot, right? But we have to remember, a lot of this is enclosure. It's like it's your washing machines, your dishwasher. It's got like
right.
There's a lot of other useful stuff.
Yeah, it's such a mixed bag, right?
The mixed bag.
As soon as like a wire touches it, it kind of becomes e-waste. At least in my mind, because you don't know, it might have a heavy metal.
Yeah, practically. And those wires, even just like the PVC coating on wires.
That's true.
That's again full of fire retardants. So
Yeah.
Hard.
What categories of waste are there? Like the E in e-waste is electronics, right? Is that right?
Exactly.
So then like I guess you have like your compost, you have recyclable. Like, are there categories of waste?
Yeah. E-waste is typically classed under hazardous waste and universal waste. I think are the 2 buckets it's typically put in.
Okay.
Hazardous meaning that there is some hazard associated with this waste. You can't just throw it in the river, right?
Right.
Like, sorry.
But your other waste you can throw in the river.
A glass bottle, for example.
You could throw that in the river?
Don't, right? But just like thought experiment wise,
right?
Throw it in the ocean. What happens to it?
It's probably not going to kill a fish.
It might even become a home for one over the next 100 years.
Right.
It's going to get smashed up. And it's going to become the sand that it once was, right? Like full circle, pretty easy. Thought experiment-wise, it's relatively benign.
Right. Have you ever heard of, and I'm curious where tires are now, but there was this Florida experiment, had to be Florida.
Oh, yeah.
Where they threw like, 10,000 tires in the ocean and they were like, it'll be a coral reef.
We'll make some reefs. Yeah.
And then you look at it now, like scuba divers come look at it and it's just a big pile of tires. Like it did not, and they're taking it all out and it's so expensive to take it all out.
And they realized that the tires, again, because of the adulterants in the rubber, not the rubber itself, there was a whole bunch of compounds in there to stop them, whatever. They needed some plasticizers and some UV agents and all sorts of things.
Right.
And that type of stuff is often really toxic.
Yep.
So you realize too late. Oh my God. So if you have 27 million F-150s worth of e-waste to deal with a year, you said like a dump is the first thing that comes to mind.
Yeah,
in the
some kind of landfill.
In the Western world, it's actually about 50-50, roughly speaking, of how it's dealt with in the Western world.
Okay, so if not a landfill, where else can you put it? You can incinerate it, but even if you incinerate it, what do you do? Yeah, I don't know. What else is there?
13.8 billion, which is unfortunately the smallest category, but also about a quarter of that is formally collected and properly recycled.
Really?
Documented. All done and said, which makes sense, right? Like you're talking about, again, like a large white good. Think about the metal content in there.
Yep.
It's worth processing. It makes sense.
Yeah.
There's about 16 billion kilograms of e-waste that's generated and recycled outside of these formal systems, but in high and upper middle income countries that have like a developed infrastructure. So I don't precisely know whether this means that they're being dumped like somewhere in landfill, or if they're just being processed informally, shall we say, maybe upcycled optimistically for a dishwasher, might be refit and refurbished and etc.
Yeah. Or I don't know if you have a stat on this, but like I think we sell waste too. We're like, please take this waste away, and we ship it sometimes. So
we do.
I'm wondering how many developed countries do that.
Unfortunately, that is a big common one as well. Yeah. And then the other thing is you end up shipping a lot of it overseas. But for, like, you can imagine, we were discussing the RoHS before from Europe, right? Yep. Now, unsurprisingly, Europe loves legislation, loves the environment, doing actually a reasonably good job with their recycling rates. They're at 42.8% of all of their e-waste at the moment. They're the best, right?
Wow.
Oceania is behind, and actually surprisingly kind of really high. I think they count a lot of Indonesia and whatnot in this, but it's 41.4% is properly recycled.
Nice.
So, my home Australia, got to pack them in the back. That's not too bad. The Americas is 30%, but granted, this is not just the USA. It's all of the Americas.
Gotcha.
And Africa, as you say, the burden often falls upon them to receive other countries' e-waste that is, quote unquote, properly dealt with and actually kind of snuck around the corners.
Yeah.
Unfortunately, they're down at the 0.7%. So,
oh, wow, 0.7. Hold on, that took a second to hit. So we went from 42% in Europe to 0.7.
Yeah.
Oh, my
indeed.
gosh.
And so it kind of begs the question of like, is there a better way that we can, one, manufacture these things, and two, recycle them in a way that means that you can get out all of this, like metal content is about half the content in e-waste, right?
Yeah.
This should be worth recycling in some way.
Right.
Is there like a safe way to get it out? And so like, what are some of the technologies behind it? Have you come across a company called Redwood Materials?
No.
So Redwood Materials, Redwood City, not too far south.
Oh, no way, that's local.
That's local.
Right down south.
Right down south. They, I believe it was started by, and if it wasn't, they were very early employees by the couple of guys who right at the start of Tesla, before Elon, that is, like kind of early Tesla. I think maybe
pre-Elon Tesla. Although Elon is a founder, so how does that work? Just kidding. There was a big controversy and he sued for it.
Yep.
But he's a good guy. All right. Go ahead.
Redwood Materials does lithium battery recycling, for example, right? So it also counts as e-waste, the batteries. And there's various ways to go about this, but like you can either chemically like strip all the stuff off, you can get some value out of it. And you think about this, think about like when people talk about battery manufacturing, it's always the lithium that comes up.
Yep.
Lithium and the cobalt. Like this is a mine, right, of high quality material you can pull out and do some value with.
Wow, huh? Okay, so they're sort of a new technology for getting this lithium and cobalt out of the batteries, is that right?
Stripping them back down, disassembling them, and another one's Li-cycle. Have you ever come across them as well?
Li-cycle, no, haven't heard of them.
Li-cycle.
Li-cycle.
Yeah, like Li, like lithium ion.
Oh, gotcha. I was like, Li-cycle. I'm like, we need to put a stop to that.
They're another one. They're actually a Canadian company, but they've got a lot of facilities in the US. They have basically come up with a giant blender, which you throw an entire battery pack in and it's submerged. And so under this like proprietary fluid of theirs, you blend up a battery pack and all the plastics kind of float to the top, all the metals float to the bottom.
Oh, interesting.
And then you strip out a whole bunch of this like black impregnated carbon material that's on the cathodes. And that sort of falls into the fluid and you can just filter it out and you end up with the materials actually properly split. So there's some promise here.
That's very interesting. Yeah, you know, I for some reason, it's almost like inductor efficiency or something like that, where I just assume that like, you know, people have just reached an ideal maximum. But I kind of what I'm hearing is like, no, there's still a lot of development that we can do to improve recycling these technologies or these materials. And so okay, so this is still kind of an active field. You know how I feel this way? You know what it is? It's internet commenters who are like, oh, the maximum recyclability is 37% or something. And I'm like, oh, well, I guess that's the maximum. I guess it's proven, you know? But it sounds like there's a lot of ways we can improve this.
There's a huge improvement, right? And so one is designing better as well. Like, you sort of mentioned this before, but have you ever seen Daisy from Apple, or the disassembly robot?
No.
Okay. So this is the other way around it, right? Like if you can design something to be pulled apart, ideally by a simpler apparatus than this bespoke robotic line consisting of like 12 different robots that you put an iPhone in and it'll read the generation and it knows it needs to pry off the screen at some specific angle and whatnot. But you can design things that, as we were discussing in the beginning, the constituents of a circuit board, if you can remove the halogen compounds, for example, then you can make it safe or relatively safe to incinerate.
Just isolating those things so that they don't all have to be processed at the same time. Exactly. You're going to be able to get a better process.
Exactly.
Yeah, that's super interesting. Okay, so, all right, I'm starting to backtrack. Now I'm thinking, wow, there is a lot more we can do on the recycling side. Like, we haven't even started intelligently pulling things out. We're putting them into blenders. Wow. Okay, that's pretty interesting.
You could imagine a future in which you might like even desolder certain components. Which is something done manually today, right? Like there's a whole bunch of people typically from what I've seen, like South Asia, like sort of Pakistan is the one place I've seen this done a lot, which will actually desolder chips and resell them.
Which is absolutely.
It's insanity. Like think about the amount of skilled technical labor required to pull those off, right?
Yeah, I sort of two anecdotes on this. One is I've bought desoldered chips before during COVID. Yeah, there was a chip supply shortage, so we were actually buying them. And then the other interesting thing is when I was in college, we would desolder old boards. Yeah. But we would do it for RPI used to have an e-waste dump, and they would put really old electronics there, and really old electronics have the best buttons. Everything, people forget, everything has touch screens now, but in the 80s, that was the era of the button, of the switch, incredible, like and they're expensive too. Yeah. Nowadays, because just huge chunk, great actuation. So we used to desolder those all the time with hot air guns.
But so you got quite good at it, actually.
Yeah,
you could sell that labor for 50 cents an hour.
You know what's funny is, chips, like expensive chips nowadays would probably be really hard to desolder. Like BGA, you probably can't even replace a BGA. But we would put these old circuit boards like in a mount and then get a little hammer and then heat it and then hit it with a hammer.
And stuff would just fall off.
And stuff would fall off. Yeah. You just get it really hot.
Yeah. Well, that's the reason actually that you're trying to remove some of these compounds, right? Like, because if you've got something in there that's trying to stop it from catching fire, you often emit something pretty nasty when it does.
Oh, it smells really bad if you heat up a chip until it melts or something like that.
Terrible. Yeah. You let out all the blue smoke. Smoke's not meant to be blue.
Yes,
right?
yes.
It's pretty nasty stuff.
Absolutely.
They're actually a class of chemicals called dioxins and furans that are probably the nastiest of the stuff that's created during that process. And unfortunately, they do fall into the persistent organic pollutant or bioaccumulating pollutant that I mentioned before.
Bioaccumulating. So bioaccumulating meaning they don't get out of your system. Is that right? Or
your system or the things that you might eat as well.
Oh wow!
Because they're very fat soluble, and so so the dioxins and furans actually it was a class of dioxins that made Agent Orange so dangerous.
Oh wow!
It was a contaminant. It wasn't even intentionally put as a component of the Agent Orange, which was a defoliaging agent in Vietnam. But as part of the manufacturing process, they accidentally manufactured a whole bunch of dioxins they put in there as well. And that's what caused all the birth defects, a whole bunch of the cancer rates and whatnot. And when you burn a PCB, a hugely variable amount of this class of chemical comes out, depending on what temperature you might burn it at and how much oxygen it had and all sorts of things. And so by removing those halogen compounds, you dramatically reduce, or in case of if you can completely remove the halogens, you remove all the chlorine and bromine, you can remove all of the dioxins and furans.
Yeah. And that sounds great because stuff catches on fire all the time. It's just going to happen.
Yeah, in electronics to bring up.
Yeah.
So I'd sincerely hope, I believe it's Japan does currently have regulation around the halogen content, but I would love to see this spread to the rest of the Western world because it would make incineration of electronics vastly safer.
Absolutely. It seems like the only criteria we care about is flame retardant. It seems like there should be a couple other things there. I'll be looking for those next time I order a PCB.
Yeah, absolutely. So with the e-waste as well, I think that it's clear that there's a lot really we can do. You can pick categories of things that are better disassembled. You can also design things that actually last a bit longer in the first place.
Yeah.
And when you do have large devices like a washing machine or a dishwasher that's worth disassembling for the metals, and the circuit board's a small constituent of that, it does make it worth recycling. Yep. And so putting into the thermal processes in the Western world, it does actually typically end up in a good place because it's worth pulling apart, worth getting the metals out and resmelting them.
Right.
There is a lot of hope. We're about halfway there in the Western world, and we can certainly do, let's say, better elsewhere too.
Absolutely. Let's get that other half.
We got it. Thank you very much, Seve.
Thanks, Matt.
Have a good one.
You too.